Hello everyone, I'm Marcus. I'm full stack software developer for Constellation. We will kick off a series of video about the Hackathon webinars. And I'm here with James, a protocol engineer. Can you present yourself, James?
Hi everyone, I'm James. Like Marcus said, I'm a protocol engineer over here at Constellation, and excited to kick off this hackathon with an intro to the Euclid SDK.
Yes. So this first one is about the Euclid SDK, and I will give a introduction. What about is Euclid SDK? So let's move forward. Well, so what is Euclid SDK? So Euclid is the Constellation SDK. It's designed to help you to set up quickly basic development environment. So you can build your Metagraph locally in your project using your extendable framework or currency framework. With the Euclid, you can easily and efficiently launch a Metagraph token to the network, offering a fast and configurable approach. Like Euclid, it was made and was designed so you can set up your Metagraph locally using a local network. Like we have the HTTP, we have mainnet, testnet, and integration net, but locally you don't need to use those networks. So Euclid encapsulate this and let you run locally a network and your Metagraph. So you can build your Metagraph, you can change your Metagraph, you can do anything with your Metagraph locally before publishing the Metagraph officially. So where you can find the Euclid. Euclid is a GitHub public repository. You can find on this following URL on the Constellation GitHub. I believe that all those links will be available on the Hackathon webpage. So you guys can use that link to clone the Euclid and start working with the Euclid. So the Euclid SDK have some dependencies. We have Docker. That is our container orchestration. So we will use containers to simulate the Metagraph layers and the network layers. All the terms, layers, and that stuff will be explained here later. So it's just an overview. We use Scala to develop the Metagraph, so it's also a dependency. Cargo is a dependency that we use to install the RGC framework. So Euclid is based using the RGC framework, and this is a framework from Cargo. We have Ansible. Ansible is a framework, is a tool that we use so we can start all the containers. We can call some remote commands that I will talk about this later also, but we have how to deploy your Metagraph officially using Euclid. So Ansible helps us on this because we have how to communicate with instances. So Ansible helps us a lot on that part. We also have the YQ and JQ. The YQ part, it's to handle it with YAML files, and that YAML files we have on the configuration of Ansible. And we also have the JQ. JQ is just like YAML, but dealing with JSONs. So we also have the requirements to run the Euclid. We need the minimum of 16 gigabytes of memory because we will run a lot of Java processes. We will run different layers for Metagraphs and networks, and this will become a heavy image and heavy processes. So we recommend to have 32 gigabytes of memory, but the minimum is 16 gigabytes of memory. The Euclid was made using the Unix operating system. Talking about the macOS, Ubuntu, and Debian. If you are using Windows, we have the DebugSL. James will explain later on the installation about some differences on installation on the Euclid on this different operating system. So we will explain everything later. Brief explaining in how the Euclid works. Like I've mentioned before, Euclid kind of abstracts the Constellation Network, the HTTP, to run locally in your computer using Docker. Like it supports both the global network and Metagraph layers, providing a local development environment. If you take a look at the image, we can see that we have the layers, like I've mentioned it. We have the data and currency of one layers. Is the layers that we will receive the transactions, is the layers that we will produce the blocks. And those layers will send the blocks to the Metagraph L0, is the Metagraph L0 layer. The Metagraph L0 layer will produce the snapshots. These snapshots, it's the aggregation of blocks and the processes. We will produce the snapshots and send that snapshots to the global networks. such as mainnet, testnet, and integration net that I've mentioned. But at this case, we will run a local global network. So we will send to our locally global network. This is the layer that I've mentioned. So we need the 3 different layers to run a Metagraph. We need the global layer, we need the Metagraph L0 layer, and we need the L1 layers. The L1 layers, you can have both layers, currency and data L1 layers, or you can have currency or data L1 layer. You need at least one L1 layer. A brief explaining the difference between those layers. The currency L1 is the currency layer where we send common currency transactions, like I want to send that amount of token to that address. So the currency layer will handle with that kind of transactions, just simple currency transactions. The data L1 layer is a little bit complex, and it will be explained later. It's the layer that will receive custom data types. So like we have right here in Constellation with the Dora Metagraph, that we are receiving full traffic data from a device, an IoT. We were receiving that kind of data, processing that data, everything, and putting into a snapshot. So the data layer allows us to handle and receive a lot of different types of data. So the Docker container that we will build on Euclid, we will execute all the layers that I've mentioned above. So except the global L0 layer that will be run only on the first container, because we need, at the test scenario, only one global L0. And to save some resources, we prefer to not run the 3 different global L0s in 3 different containers, just to save some resources. And that's the reason that we have only on the first node at this scenario. So how do we set up the containers using Docker and everything? So Euclid uses the Ubuntu 20.04 as the base image for the Docker container. So we clone that image, like we have the Docker files, we have the Docker Compose files that will be shown later, that build that images, and our base image is the Ubuntu 20.04. And with this Ubuntu 20.04, we need some dependencies to run the processes, such as Java, Scala, StableGet, and yeah, go ahead.
SBT, sorry.
Yeah, SBT definitely is together with the Scala. And you can see right here that we have 2 types of Docker images. We have the Metagraph Ubuntu. This is our first image base, is the Ubuntu, and then we will install the dependencies that we mentioned, such as Java, Scala, SBT in Constellation dependencies. Because to build a Metagraph, we have the dependencies from the Constellation code base from Constellation. So we generate all the dependencies and everything and put on this Metagraph Ubuntu image. Later, we use that image, this Metagraph Ubuntu image, to build a second type of image called Metagraph base image. So we will use this Metagraph Ubuntu image that we just built as base, and then we will build our Metagraph on the top of this image. So we already have all the dependencies installed, like Java dependencies, Constellation dependencies, everything is already installed, so we don't need to repeat all that processes, and we can focus directly on the Metagraph development. That's the reason that we have this division between these 2 images. Well, Euclid have a lot of features and a lot of stuff, and we need a way to configure that the Euclid, like to say how can we configure everything, like what key files that I use, what version of Metagraph I will build. So some configuration like this one, we have a file called Euclid.json. This file is located on the root path of the Euclid. If you clone the repository, you should see this Euclid.json file. And this is the configuration file for Euclid. So everything is configured there. Such as your GitHub token, you need to create a GitHub token. And this GitHub token should be used to clone some stuff from GitHub, some Constellation dependencies, like I've mentioned. To generate that dependencies from GitHub, we need that token. Also, you can select what layers that you want to run. Like I've mentioned earlier, you don't need the two L1 layers if you don't want to. Let's say that I only want to send currency transactions. I just want to mint a token. So I can select to run only the currency L1, not the data L1. So I can select what layers that I want to run right here. We also have my token key files information, like what will be my B12 files that I will use to run my Metagraph, my key files. Right here, I can put the information like the name, the alias, and the password of the 3 files. We have 3 files here because we need at least 3 nodes to work correctly. So that's the reason that we have 3. By default, we have this token key, P12 file. It's a generic one. We use this to the token environment. So please be sure to use this only on your test environment. This cannot be public because we have security issues there since the password and everything is shared. So this is only for test purposes. We also have the snapshots fee information. Right here is a more detailed one, but I will give a brief overview. We have the fees on the snapshots when we produce currency snapshots to send to the global layers. We have fees that need to be charged for each snapshot. We have some calculation on those fees. I believe that the link explaining everything related to the fees will also be on the Hackathon website, so you guys can take a look and see what is these fees, how these fees will be charged. So everything will be there. We also have an option to have telemetry configuration. Like we use Grafana right here, and we can set up a Grafana to monitor your nodes locally. So you can see that we have an option called Start Grafana Container, and that information, if it's set to true, you have a Grafana instance running locally, and these Grafana instances have 2 dashboards to monitor the global and Metagraph layers. There you can see information like number of nodes, healthiness, and a lot of stuff that you can see through Grafana. And for the very last, we have the deployment information. After you build your Metagraph and everything is tested locally and it's working as expected, you need to deploy your Metagraph to the public networks. Like I've mentioned, we have the public networks, integration net, mainnet, and testnet. So we are ready to go to the public network. So this deployment information will help us to call the remote commands that we have to deploy your Metagraph into our networks. I will explain a little bit later what is about this remote stuff, but that's it. And the last part of the introduction, we have the directories, just so you guys can be familiarized with the directories. When we clone the Euclid development environment, we have by default 4 important directories. We have the infra, we have scripts, source, and Euclid.json. Euclid.json is the configuration file that I've mentioned earlier. And infra directory is where we have the Docker files, the Docker Compose and the Docker files inside the Docker folder. And inside the Ansible folders is where we have the playbooks, the Ansible playbooks that will run the Docker files, will provision everything that we need, and then start my containers with all the information. Like starting my node, joining my node to a cluster, everything will happen through Ansible. So the playbooks, we have the division into local and remote. To developing locally, you can focus on the local folder. This local folder contains all the information about the Ansible working. The scripts folder is where Hydra lives. I will explain later what is Hydra. Like Hydra is the command line tool for Euclid. I will explain better about Hydra later. But there is where lives all the Hydra commands, like Hydra install, Hydra build, Hydra start, destroy, deploy. Everything is located below this directory, this scripts directory. And for the very last, we have the source directory, where we have informations from the global layer, like the Genesis file, and the Metagraph layer, the Genesis file as well. The Genesis file is just the initial balances that you need to provide to some wallet. So let's say that we'll build a Metagraph and I need to have a treasury wallet that needs to start with 1 million tokens. So I will put the information into this genesis.csv file. Like my address will start with that balance. Besides that, we have the P12 files directory. There is where we're going to put all the P12 files, the key files. So it's a requirement that we need to provide all the files on this directory. And for the very last, we have this project directory. This project directory is where you're going to live your Metagraph project by itself. So we have some install commands that James will show up later that will install the Metagraph and everything, and we'll put your project, your custom project, your Metagraph project on this project directory. So this is for introduction, that's it. I will let James talk about a little bit the installation processes and all the dependencies. And that's it. Go ahead, James.
So for this portion of our tutorial today, we're going to be going through how to actually get Euclid set up in an environment. And we'll note that our Euclid process primarily targets Unix-based operating systems such as macOS, Ubuntu, and other Linux distros. But there is Windows support via Windows Subsystem for Linux, or WSL. And that's what what I'll be showing you today. But for any more information about the commands we're running, or the different systems that are supported, you can visit our documentation under the Quick Start Guide for the SDK. And I'll just go ahead and show you that page right here. So you see we have the dependencies and the different commands and things that are needed to be run. So let's go ahead and get started. So I will be using specifically a Windows host system and a WSL Linux, or like a WSL hosting a Linux kernel as like a VM. So this is just a very simple way to get this going. A lot of the, I'll be sure to point out what is specific to this WSL instance, but and as well as the points that are kind of common across all Linux variants or Unix variants. So here you can tell this is this fresh install of Ubuntu, so it's actually finishing up its install thing. So let's go ahead and minimize that, and we'll just make a new user, and we'll make a password. And so it's just finishing up its final install bits. All right. So when that's done, there we go. All right. So now we have a fresh new install of Ubuntu. And the other prerequisites that this guide is going to assume is on my host system, I have Docker desktop. So if you're doing this on a fresh Ubuntu install, maybe like a virtual machine in the cloud, one of the first things you might need to do is install Docker into your Ubuntu image. In this case, since we're doing this where the host system is a Windows operating system, and there's just a Linux kernel, a subsystem Linux kernel, we can use this kind of integration introduced by Docker. And if we go into settings here under resources, there is actually a WSL integration. So actually, I'm going to go ahead and while this is, I'm going to turn this on right now, and I'm going to actually restart Docker, and this will make Docker available to me in my, and there we go. So now I have Docker available in my Ubuntu instance here. So let's go ahead and move this out of the way. Okay, so then the first thing we're going to do is we're actually going to update some dependencies, and we're going to install build essentials, which at least in this kernel does not come pre-built. Your Linux kernel may vary, it depends on the image it produced or like you download. But build essential is just a bunch of like GCC compiler and a bunch of internal libraries for compiling from source other things, which is needed for some of the other steps later on. Okay, I hope Discord does not keep doing that. Let's go ahead and there we go. So we're just going to wait on build essential to finish up. And there we go. Okay, so that's all done. Then next, we're going to install Rust and Cargo, which is needed for us to be able to install argc that Marcus mentioned, which is used as the command line parser for the Hydra command line processes. So we'll go ahead and we're downloading the script, which is going to take care of installing Rust and Cargo for us. Okay, so that was successful. When this is done, you actually, this little bit says you need to update your kind of your source, your shell environment. And I find the easiest way to do that, you can try to run these commands. I find the easiest way is just to go and let's launch a new instance of the shell. And so here we go. So now we've got a new instance of our shell in the Ubuntu 2022 or 2204 environment. And so the next thing we'll do is we go ahead and we use cargo to install argc. So that's what we're doing now, just with cargo install argc. And so then it's downloading, and it downloaded all of its dependencies, and then now it's compiling everything. And this is kind of what you need Build Essential for, is to do all this compilation stuff right here. For some reason, I don't know why this part takes so long, but we can probably cut out some of this dead time. Okay, so now we've got argc installed. I'll go and clear the terminal again. Okay, and so then our next step is, now we've got Rust and cargo and argc all done. We're going to go ahead and transition to doing the Ansible dependencies. So the first thing that we can do is install pipx. So we'll go ahead and do that. And then we'll actually use pipx to install Ansible for us once it's complete. Okay, so we got that done. Clear our terminal once more. And now we'll go ahead and use pipx to install Ansible along with all of its dependencies. And so we install the full Ansible suite because we need some of the Docker components that are installed with it. So we'll go ahead and let pipx do its thing, installing Ansible. And as Marcus mentioned, Ansible is used as the kind of the build manager for doing all of the containerization and automating all that for you. So Euclid is a great framework and a great tool because it really it lets you, it takes care of, automates, that's the word I meant. It automates all of the kind of necessary tooling that you need in order to actually work on the application that you care about, your like Metagraph business logic of, you know, a marketplace or a DEX or whatever you may have you. All of that is taken care of in the Metagraph layer between the L1, either the currency L1 or the data L1, and then the Metagraph L0. And then that has to plug into a global L0.
Yes.
And so sorry, go ahead.
A quick note about the Ansible. If you already have Ansible installed, but it's previous to the version 2.16, it will be rejected. We have a validation on Euclid, and it's a requirement to have the Ansible greater or equal to 2.16, because I'm not sure if the compile or if some functionalities that is not available on an Ansible previous this version. So it's just a note.
Right, and then also one of the reasons that I chose an Ubuntu 2204 instance to act as the host for launching Euclid is because it comes with a higher version of Python by default, and the newer version of Ansible that Marcus just mentioned requires Python 3.10 or greater. So if you're having issues with only having Python 3.8 or lower versions of Python, you might have to do some installation of other Python versions, or like I said, I think the easiest way is just to use a newer, one of the newest distro images, because that seems to eliminate a lot of these little errors I've come across. Okay, and then finally, once we have Ansible installed, we'll go ahead and do pipx ensure path, and this will actually update our path and everything. So now Ansible is good to go. And then our last step is I go ahead and install JQ and YQ manually. Your distro may already have it installed, so that's worth checking. But for this sake, it's just a couple of commands. So that was JQ, and then here for YQ, we actually have to go and add a PPA. So we'll do that, and once it does all this thing, okay, and then sudo apt update and sudo apt install YQ. So I just update, since we just added this repo, and just to be sure, we'll just update all of our things, and then it went ahead and installed YQ for us. And there we go. That's all of our dependencies are already set up. Now, the next thing, that's once you have all your dependencies in place, we want to go ahead and clone the Euclid repository. In order to do that, I find the easiest way, especially in these remote environments, is just to generate a new key, which can be done with SSH keygen. And then we're going to change the type to this add 25519, which just specifies an elliptic curve and a bunch of technical mumbo jumbo. But then after -C, we can add a comment. And this comment is like a human readable thing that will let you as the developer remember what this key is for in the future. So I'm going to write, Ruthie, Ubuntu 22.04.2, because I've been doing this a couple times. So that's where I want to save it. I'm going to take the default place. I'm just going to, for the sake of simplicity, I'm not going to put a password. There's our little thing. And then if we want, we can view the public key by catting out .ssh id _.pub. And so now this is the public key associated with the private key here. So this file contains the private key, this SSH private key, and then here's the public key. And what we're going to do now is we're going to take this public key and we're going to copy it. We're going to go over to GitHub, and I've already gotten to the right place, but you can get here by clicking on your profile picture, clicking settings, and you get to this place, and then SSH and GPG keys here on the left. And we're going to go ahead and add a new SSH key. So I'm going to put a similar name, Ubuntu 22.04.2. I'm going to paste in my public key there. And now this is just authorizing that public key to GitHub for us. And so now I'd be able to go clone the repo, but there's one more thing we need to do from the settings page. So we're gonna take a little bit of a tangent to go do that. So before we go and clone the repo, let's go ahead and create that GitHub token that Marcus mentioned. So on the left, you can click developer settings and click personal access token. And then you should see your personal access tokens here. I already have one created for this, but what you would do is you can just click generate new token, give it a name, Ubuntu walkthrough, something like that. It's recommended to give it some sort of expiration date. So let's just go ahead and give it something close or something low, since I'm going to go ahead and delete this afterwards anyway. And then the scopes that we recommend are repo, workflow, read packages, and gist. And there's more information for kind of a more in-depth. There's documentation on this as well, if I'm going a little bit too quick. Okay, but now we have this secret string, and you should never ever do what I'm doing right now, which is broadcasting that string to the public. Which is why I'm going to go delete it. But this will now let automated processes interact with GitHub on my behalf. Kind of similar to what the SSH key does, but on a more, as a user level. Okay, so let's get rid of that. And then we're going to come back to our Ubuntu instance. All right, let's see. Okay, the next thing we need to do is clone the repository. So come on, there we go. So I always, this is not needed, but I do this cd git, and then we're gonna clone the repository into, come on, as just git clone, and then git at github.com, that the URL that was given previously. And so now we're gonna clone the repo. Yes, I accept that host. And we let everything download. Then the next thing we do is we can go into Euclid and we can just make sure that everything works. So I'll let Marcus describe more what this Hydra is, but just for the sake of simplicity, we can just quickly, this little command scripts Hydra-h will, verify for us that Euclid is working. Insofar as it displays all the help, it displays the help manual and all the commands that are available for us. So we can be assured that Hydra is working as expected at this moment. So the next thing we want to do is put our token into the Euclid JSON. So we can do that with, VS Code or Vim or VI or whatever you'd like, whatever text editor you like to use. I use Nano. Go ahead and drop my token there, save and exit. And so now I have my token in the in our Euclid JSON. And then I'm gonna let Marcus go into the specifics of this, but just for the sake of showing how everything works, the next command we're gonna do is we're gonna use Hydra, and then we're gonna install a template, and we're gonna use this NFT template. So there are multiple templates available. You can see them all by doing -- list, and these are the names that you could pull from. So we're just going to go ahead and install the NFT template. And what this does is it detaches our Euclid repo into a new state. So now it's kind of available for you to go and attach to a new remote repository. As well as it places the, where is it? Why? What? Source. Oh, okay, there. It places the NFT Metagraph files underneath source project. And so this is, going back to the folder structure that Marcus showed us just a minute ago. All of the Metagraph, like the Scala SBT project, is under this NFT folder here. All right. So
yeah, and it's worth to mention real quick, James, that when we install a template like this, such as the NFT, if you take a look at the Euclid.json file, initially we have the version 233. But let's see that our template is on a different version, 280, like we have at this moment. We can see that the template automatically changed the field project name to NFT and changed the translation to the 280. That is the version that the template is operating right now. So right. It's just a note.
That's a great point, because if we look at the original Euclid JSON here on the remote repository which is what we had originally, this was Constellation 233, and the project name is just kind of a default placeholder name, custom project. And so as Marcus was mentioning, like the install does a couple of things, among them updating this version to the version that is supported by that template, as well as changing the name and some other kind of background stuff, I believe, right? That's like it detaches the Git. Yeah. Okay. Well, we've made it this far, so why don't we go ahead and try to just build our NFT project, just to ensure that everything is working as expected. Oh, I must have already had it available. So normally, if you when this is the first time, it kind of goes, this can take a little bit of time. But one of the great things that Marcus has done to help improve development is, because I had gone through this process a little earlier and I have the image available on my machine, it just found it. It's already available.
like just interrupt you. If you take a look at the logs, you can see from the top we have a green log called Ubuntu for Tessellation 2.8.0 already built. So the first time that you run this, and the Metagraph Ubuntu is the heaviest one, it will build this image, and this, like I mentioned, is a heavy image, and then we will download dependencies, build dependencies, create directories, put files, move files, and this can be time consuming, like 50 minutes, 20 minutes. It depends on your machine, on your hardware. It will depend. But the greatest part, like James mentioned it's because this will be done one time. And then once you have the image ready, the next time that you build your Metagraph, we don't need to build the Ubuntu again because it's already done. So we will focus only on the Metagraph. That is the second step. It's the second log. It's called Metagraph-based image.
Right. And just one point of note, your tessellation for your Ubuntu image is based on the tessellation version. So as long as you're not updating this tessellation version and you've built it, you only have to build it once.
Yes.
But
if you change the tessellation version, it will build a new Metagraph based on that tessellation version. So tessellation version based it. You can see that right above this green log that James just mentioned, we have the Metagraph project tessellation version and tessellation version provided on Euclid.json. We do the validation. So let's say that your NFT is on the tessellation, let's say 2.5.0, but the Euclid is 2.8.0. So if we have this incompatibility, we will throw an error saying, hey, you need to be consistent on tessellation versions. So we have this validation. And every time that you change the versions and you don't have this as a Docker image, it will build a new Docker image for you on Ubuntu. Maybe James can show the images on Docker with the Docker images command, and you can see that we will have the Docker image according with the name.
Oh, sorry.
Docker images. Yeah, exactly. If you see, we have the Metagraph for Ubuntu 2.8.0. So it was created exactly.
I'm actually I wasn't expecting it to be there. I thought it had cleared out when I blew this away earlier. So I'm kind of glad that it saved us all that time. You can look at, there is a way to if something were to happen, or maybe this process is failing, like hopefully that's never the case, but there is a way to force that cache to not be used via this no cache command. If you need to force, or you need to, like for some reason you're debugging and you need to know that you're starting from a clean slate. From my use in practice, I rarely have to use this no cache command. The Docker images are pretty stable for the base images, right? For the tessellation 2.8 and so on. Okay, well, since we already have it built, maybe I'll just start it up really quick. Is that okay? Or were you going to do that? Okay.
No, okay. Let's run, and we can show the Ansible playing when the start Genesis command.
Yep.
Oh, maybe we have a little incompatibility.
I had to do this. Yeah.
Earlier.
I have to restart another session, and then cd Euclid.
Yes.
And then we'll scripts, Hydra, start Genesis. Yeah, it's something similar to that, like the
It's not updated the current section. Like you can force, but it's not updated. So like we are running start right now. If you see some red logs like this one, back installed, don't be afraid. Like it's because Ansible returns some fake errors when we check for some libraries already installed. Like at this case, we are just ensuring that pip3 is installed. So it throws an error, but it's just us checking if it's installed. If not, we will install for you. So it's expected.
And so here you see we kind of start from the bottom up. We're first doing the global L0 layer, and we like launch it and copy some files, and then we poll and wait for it to respond. Oh, my bad. And then once it responds, we move on.
Yes, exactly. We will try to start a global L0 first, then Metagraph L0, then the L1 layers. Currency L1 first and the L1 last, or if you have one of the layers, just the layer that you choose.
Right. And those are just, while we're waiting on this to go, those layers within the Euclid JSON file, these are the layers that Marcus is referring to. And so you always need these two and at least one of these two. Is that correct?
Perfect. Exactly.
Okay. But you can, as shown here, you can run all four. Like you can run a full thing. It just takes a little bit longer.
Yes, exactly. Because on these processes that we are running right now, the first thing at the top, we'll start the 3 containers. And then with these 3 containers, Ansible is communicating with the 3 containers, like sending files, creating directories, starting Java processes, checking if the processes is healthy. So we have a lot of stuff happening in background. And that's where the Euclid shines, in my opinion, because we like hide all this process from users. Is everything happened behind the scenes through the Ansible and the Euclid? It's a complex project. It's a complex stuff that it's easily simplified by Euclid.
And even better, there are even commands to do what we're doing. Everything right now is local deployment, but Marcus has done some really great work to connect this to remote deployments. So if you can get the benefit of this command line and a lot of this automation, even for pushing into public environments like on AWS or Azure or any like Google Cloud, those sort of hosted environments.
Yes. And the structure of containers and remote instances are the same. Like you should see that we have a code directory and we have the folders. The name of the folders, the structure, the directories, it's the same local and remote. So we have this stabilized. So we will run locally, and then when you deploy, you should see exactly the copy of what you have locally. So yeah, that's it.
And so everything it's all up and running now. And then just to clarify what Marcus mentioned a second ago about the 3 containers, right? You can basically think of them as 3 computers, 3 servers. You can call them Metagraph Node 1, Metagraph Node 2, Metagraph Node 3, and then each one of those things is running, these. So Metagraph Node 1 is running 4 different applications, right? It's running this global L0, the Metagraph L0, their currency L1 and data L1, and they're separably addressable via this different port, right? So the global L0 is on 9000, Metagraph L0 on 9200, and so on and so forth. And so these are the 3 nodes, and then the lines are, I think of them as like the different applications running on each node. And of course you have the clusters of the different groupings of the different applications across the nodes.
Yeah, like James has mentioned it, when we search by /node info, we are searching about individual information of the nodes. When we call the cluster info, if we open any of these URLs, you should see the information of the entire cluster, all the nodes present on that layer, on that cluster. So that's the difference.
Right.
Yes, exactly.
So here we're going to look at just the global L0 9000 node info. So this is just the information for that one global L0 node. But like Marcus mentioned, we can also go look at the cluster info for that one L0 node. Yeah. And since there's only one, we only expect one member.
Exactly.
But if we look at another, sorry if I can get it click in the right place. But if we go back to L0, we should expect there are 3 members of this L0, of this Metagraph L0. So when we click that and we preprint, we can see exactly that. Yeah. Is there anything else you think we should go over before I hand it back over?
No, I think that's pretty clear. You can go back to the Euclid real quick. You should see that we have the Metagraph ID information showing up here. This is the identifier of your Metagraph. It's just like a DAG address, like exactly like a DAG address that you are used to see, but it's the identifier of your Metagraph. So this information is really important because this is the information that later you share with us that we can allow you to run the Metagraph on our networks, on the public network. So be sure that the Metagraph ID shown to you on that command, it's important. So you need to store that information.
Yep. And it is also like a stable identifier, right? That's
yes,
like,
exactly.
Once you've generated it for that network, that's the same identifier you'll continue to use.
Yes, exactly. Like once you generate a new Metagraph ID, like to generate the Metagraph ID, we have some processes that will be explained in the future webinar series that we will produce Genesis snapshot and some stuff. So this Metagraph is unique and immutable. So once you generate, this is your identifier, and no one will never copy or be equals yours.
Right. So it should be equivalent, or for like equivalents in other networks, maybe like a contract address in Ethereum.
Yes, exactly.
Cool. Alrighty. Well, I'll stop sharing my screen and hand it back over to you.
Sure. Cool. Let's finish this. Just a little bit about the tooling that we have on Euclid. So I will show some toolings that we have real quick. First thing is the SDK developer dashboard. This is the tool that we build that is made on Next.js project. It's also on the Constellation GitHub, the same GitHub than Euclid. It's called SDK developer dashboard. With this application, you can check your snapshot and transactions in both layers, global and Metagraph levels. So you can see on the image that we have the green one is the Metagraph, and the I believe this gray one is the global layer. We also can see the cluster information, like the number of nodes, the IPs, exactly like James showed up at the end of the start Genesis command. We have the same nodes on the cluster metrics. And to configure this, you just need to go on .m file and put the URLs of your Metagraph. You already see the URLs at the end of the Euclid execution, so you just need to copy the URLs and paste on the M file, and this should be enough. When you start the application, you should see the metrics from your nodes, your clusters. Speaking of metrics, we have, like I've mentioned it, the Grafana, the telemetry. We can use the Grafana to check the telemetry from a Metagraph. On the Euclid.json, we have a field called start Grafana containers, and you can set to true in Euclid.json to start to see your metrics. It will be available on the URL localhost 3000, and you'll be prompted to provide a user and password. By default, the initial one is admin. After you enter the first time, you'll be requested to change your password. You can put any password that you want. And this Grafana, by default, came with two dashboards, the currency and global dashboards. There you should see metrics like the consensus time, consensus duration, number of nodes in each cluster, and some telemetry information from your Docker instances. So you can use this to get some information. And I believe that the most important part on Euclid is the Hydra. Like, what is the Hydra? James used the Hydra, but what is? Like, Hydra is the command line tool of Euclid. Everything happens using Hydra on the Euclid. This tool, the Hydra, it allows to perform various operations on your Metagraph. So we have the build, we have the start, we have the destroy. So let's see that I'm not happy with my Metagraph and I want to start from scratch. So I can call the destroy. It will clean everything for you, destroy the containers, and we will start from scratch when you build and start again. The Hydra, it's built using the RGC framework. And for each command, you have the option to have a -8 to get some help. James has showed up some helpers, and you can use the -8 for all the commands to see internal helpers. So we have this option. You can take a look when you start playing with Hydra. Each command line includes a description and of the functionality and the parameters, because I believe all the command line, the command options of Euclid, we have some parameter that we need to receive. Like James has showed up that we have the build, and we have options like no cache. Let's say that I don't want cache at all. I want to build everything without cache, so I will provide this flag. Let's say that I want to start running right after building, so I have the run flag as well. So we have some parameters that I can provide. Right here, I have a list of all the current commands that we have. We have the install and install template. This is the first one, and this is used to install the templates. We have the build, where we build the Metagraph to generate the images, like I've mentioned it. We have the start Genesis and start rollback. The start Genesis is the command that will start from scratch. Like it will start from snapshot 0, snapshot completely scratch. But let's say that I'm running locally my Metagraph and I don't want to start from Genesis because I just want to resume my last execution. So I will not destroy my Metagraph. I will just stop. I will run the stop command. And the next time that I want to run, I can easily type start rollback that it will resume my last execution. It will not start from scratch. We have the destroy command. This destroy command will delete completely the Docker containers. It will remove everything that you have worked. So be sure to call this command only when you really want to destroy everything. Besides that, we have the purge that not only destroy the containers, but will clean up the images. So need to be even more caution with this command. The status command is just to show the status of your containers to see if they are running, what layers is running on each container, the URLs, the Metagraph ID information, and everything like that. This section, the remote section, it's when your Metagraph is done and you are happy with it and you want to deploy to the networks officially, we have these commands like helpers to deploy to you. You only need to provide information to the Ansible host file, like you will create your instances on your cloud provider. It can be IBM, AWS, Azure, any provider that you prefer. Provide that information on the configuration, Ansible configuration, and then the commands will do everything for you. Like the remote deploy will deliver your Metagraph, construct the directory, just like the build locally. It will do everything for you in remote, install the dependencies, send your files, and let everything ready to go. Remote start will trigger, just like start Genesis, will trigger your Metagraph. This will start your Metagraph remotely. Remote status, just like status locally to see the information. Remote logs, you can see the logs of your Metagraph on each layer, like the logs of L0, logs of L1, to see if everything is working, if you are trying to debug, find some details, see if the process is working correctly. You can check the logs with the remote logs providing the instance and the layer. We have the remote snapshot fconfig. This is the latest command that we added on Euclid. This will set up to you also the fee configuration remotely. So we will need to provide the owner and stake information on the Euclid.json. And when you run this, it will send the fee messages for you automatically remotely. So this is not important right now. Like if you are starting to work locally, focus on the local commands first to see if everything is working, to see if everything is as you're expecting. And in the future, if everything is like you're expecting, you can focus about this remote commands. We have some documentation and we have some details about this command as well. The update command is to update Euclid. Like we release some versions with fixes, with new features, just like this remote snapshot fee that I've mentioned, the latest one. We have the update command that will update your Euclid without cloning again. So let's say that I'm on the Euclid 090 and I want to update to 011. I can. It's just running the update command and it will update for you locally. Well, the logs is to get the logs from the container locally. So I want to see the logs from my containers. I can call this command through Euclid. And we have this monitoring service. I will talk about the monitoring service in the next slide, but it's a service that we have that monitor your Metagraph. So let's say that your Metagraph stopped producing snapshots. We have a failure with your code. We have let's say that your instance gets stuck on your cloud provider and your Metagraph stop it. This service will watch your Metagraph, watch your layers, the healthiness of the endpoints, and then if needed, we'll trigger restart and alert for you. You can say, let's say that I want to send an Opsgenie alert or a Slack message, I don't know, when your Metagraph is offline. So the monitoring service will do this for you. It runs at every 5 minutes. To see the health of the Metagraph. And if your Metagraph is unhealthy, it will trigger for you the restart and will send a message to you saying, hey, your Metagraph is offline. I will try to restart to you. If it fails, it will send another message say, hey, I couldn't restart for you. Take a look manually. And then you can take a look and investigate to see why the Metagraph can't be restarted automatically. So we have these 3 commands regarding the service. The install that will install for you the Metagraph, the monitoring service locally. The deploy, so we can deploy this monitoring service in another instance. You can select a 4th instance, I don't know. a separate instance that will monitor your Metagraph instances. You can deploy to this instance, and then you can trigger the remote start monitoring service that will trigger the start of this monitoring and start to watch your Metagraph. Let me see. Like I've told, the Metagraph monitoring service is a service. It was built in Node.js 18 or higher. It uses another package called Constellation package for monitoring. This is a package that we built, and we maintain this package where we introduce new features, such as alert services, let's say, new conditions of restart and everything. You can take a look at the README of the Metagraph monitoring service. You see that by default we have some conditions, but it's completely customizable. So monitoring service, you can play, you can put your conditions, you can choose the alert service that you prefer. We have a lot of options there that you can play around and discover. And I guess is it. We know it's a lot of information. Euclid, it's a great tool, but we have a lot of options there. So you guys need to dive into the Euclid, take a look at the READMEs, the documentation. We are here to help as well. We have the communication channels. We have the email. We have the Discord. We have a lot of options to help you guys. So this is the introduction of Euclid. We're going to have another webinar series that will teach more about Metagraph, but this is just the initial introduction and showing to you how the Euclid works, how to install. And thank you. I guess it's this. Do you have anything to say, James?
No, I think that was a great job, and I hope everyone comes up with some great metagraphs. And if you find any bugs, please let us know.
Exactly.
But hopefully we ferreted out most of them for you already.
Exactly. If you find any bugs or any issues with Euclid, please let us know. We are always improving and hearing the community, so we are here to help.
Definitely.
And I think that's it. We are excited to see what Metagraphs will be built in this hackathon.
Awesome.
Okay.
Thanks, Marcus.
Okay. Thanks, James. Bye.